Welcome everyone. Today we have our 650 episode, very special episodes. I want to give special thanks to our speaker from day one, those who continuously support World Talent Economy Forum. And today we will discuss about how do we beat bacteria. We have our world famous speakers and our board of advisor, Professor David Smith and Professor Rob Enderley, both of them actually our board of advisors, and how we engaging right now with this uh, South Asia and Asia Pacific people, organization, corporations. I want to give very, very special credit to our speakers because for their support, we get a very, very big audience, both in online and offline, and we are solving real problems. So their dialogue, their discussion, their guideline, their strategy become a very, very important issues, especially for policy development. Uh, Country like Bangladesh, India, and Pakistan, and Malaysia. So first, I would like to give chance Professor David Smith. What is your advice, guideline, strategy, and some internal experience from USA?
Well, Sharif, thank you this morning. And the topic of bacteria is a very interesting one because, uh, as you know, I feel more comfortable in technology, but this one is just fascinating because of the way it works. And in some ways, bacteria is actually one of the easiest things to beat. The way you can uh, kill bacteria is you heat them up to a high enough temperature that it kills them, and bleach kills off nearly all bacteria. But the problem is we can't simply heat people up enough or give them bleach while they're ill because that would probably kill us as the bacteria as well. So you begin to look at ways in that it's a simple problem. It's a very complex problem as you get there. And particularly as we look at how the human race has responded to bacteria over the centuries. Back in 2013, The Guardian put together a list of what the top 20 science questions were for the world. And the bacteria made the cut for those top 20 science questions for some of the kind of the wrong reasons. And so, your question of how do we beat bacteria? And the corollary on that is why do we need to? Bacteria is really arguably one of our oldest ancestors, and has been around, according to some of the estimates, for over 3.5 billion years. And so, bacteria, where Homo sapiens, it says we've been around for about 200,000 years. So, bacteria has over 3.4 billion years on us. So it's been here before. Cyanobacteria was probably the first, and it was from part of how photosynthesis produced oxygen, which led to what is known as the Great 1.5 billion years ago. Bacteria has moved from the ocean to nearly every surface, every habitat of the earth, from soil to skin to even extreme temperatures and things like frozen lakes, and even the bottom of the ocean is now teeming with bacteria. And I mean, there's hundreds of different forms of bacteria that we see in different areas, from what we see in whooping cough, Lyme disease, diphtheria, uh, pneumonia, Legionnaire's disease, tuberculosis. I can go on and on. And you begin to see it and how it's transmitted. And, it's not really bacteria's best interest to work to kill the host. And that's where we're seeing part of the other part of it today. We have developed numerous medications that can be used with bacteria and to manage it and to help combat it. But what has happened over the years is bacteria has developed resistance by alteration, mutations of itself. Uh, we have seen that now bacteria is producing other enzymes. that affect its use and the mechanics of it. So in the alteration sides, these mutations occur in the sequence of the nanotoptides in the bacteria DNA, which alter the amino acid sequence of it, which changes how our medicines can be used for it. And part of what we've seen is you, with the overuse of antibiotics to combat bacteria, we've seen these mutations occurring faster and faster. And then in some of the antibiotics, such as penicillin and others, enzymes are often produced by bacteria that are actually altering the antibiotics. So the bacteria has set up a defensive mechanism where they actually say, here's the antibiotic, let me release these enzymes, and let me render it ineffective. And this enzymes, they've also, in recent science, can understand that it's leaping from one bacteria to other bacteria types. And also, our body has responded some in that our body has been becoming more efficient at removing antibiotics from our body and pushing them out. And in doing so, we have a lot of places where we're looking at how to combat bacteria, but it's because resistance because of these defensive mechanisms, because of the body's own reaction. And we're also seeing something where they they're doing what's called jumping genes, and these are DNA sequences that change their positions in the genome. And what we're seeing is some of the uh, bacteria's resistance to the antibiotics. We're actually seeing some of this gene jumping happening, where the chromosomal DNA is being reduced to a cyclomed DNA, and they're transposing themselves in different ways to be able to uh, have the bacteria resist the drugs so that it can become uh, the bacteria can win. And so there's a lot going on in this area, and it's one where I'm really anxious to see what Rob has to say about it, because I I just see too much bacteria, and climate has to deal with bacteria. Your food you eat, what your societal conditions are, and but it's one that is going to become even more of a cat and mouse game going forward, because the resistance to the antibiotics and other things has become so high that we're constantly having to reinvent
Professor Rob.
ourselves around it. So, Sharif, thank you, and I'm interested to see what others say.
Professor Rob.
Okay, so the topic is fighting bacteria, and we've certainly seen how not to do that during the COVID-19 antivirus rollout. You can't really fight a bacteriological hazard if the people that you're trying to protect aren't on board with the protection that you're proposing. And so at the heart of fighting bacterial problems is training and education. Making people aware of what is an unseen killer or an unseen infector, depending on the nature of the bacteria, and then walking them through what you do to protect themselves against both getting infected and in spreading bacteria infections, or contamination, and particularly with regard to food services, the training in cleaning is often lacking. The cleaning crews are brought in. They're often staffed by people that are not formally trained, that are told to go wipe something down or clean something, and they may be wiping things down and cleaning them with rags that are covered with bacteria. And so instead of making things better, even though they look cleaner, the actual practice may be spreading bacteria on a surface, when then that bacteria gets in the food, and then somebody that's immunocompromised gets sick, or depending on the type of bacteria, they get the related sickness as a result of the contamination being spread to their food. And we have practices that probably should be discontinued. Shaking hands, for instance, and going to events where they're finger food events, buffets. I mean, but right now, people that are immunocompromised or older are being told to avoid buffets like the plague. The question is why do we have buffets at all if in fact we cannot contain the bacterial spread onto the food when people are doing it and are using it, and the sneeze guards and everything else that are being used to protect the buffets. If you've ever seen a video of how bacteria spreads when somebody breathes or sneezes, the screens aren't that effective. That they block direct access to the food, but air moves and it moves around things, and the bacteria moves with the air and can still get on the food, keeping large numbers of people away from a food source would seem to be a healthy practice if you want to contain the spread of any type of bacteriological infection or spread. So it really begins with education. Right now, people are undereducated with respect to how diseases spread, how to protect against disease spread, and the practices that have been taught to them for decades in terms of greetings. Kissing is certainly even worse than shaking hands. And certainly I knew as a child getting kissed by my older relatives wasn't something I relished anyway, and would have been more than happy to give that up. But children are a significant source of bacteriological spread. And so because kids play with each other, their immune systems aren't quite developed. Especially if they haven't been nursed on mother's milk, their ability to contract an infection is high, and their ability to spread infection is very high, both amongst other children because they're in contact, and to adults is high. So understanding the spread of bacteria, understanding how to isolate and why you need to isolate, understanding the need for antiviruses, and the fact that the antiviruses really don't embed electronics in you or turn you into mind-dead drones. At least they haven't so far. But making people comfortable with the medical institutions that are there to protect them are also important, and a lot of that has to go towards making medical institutions more transparent. The sense that an awful lot of the activity that goes on in the medical profession is concealed from the people that use that profession is problematic because it leads to distrust. And so at the heart of the problem is education. If people are aware of a problem, if they believe that the information that they are receiving, they can be better prepared to mitigate the problem that these kinds of problems and better protect themselves. I'm not sure what's ringing. I don't think it's me. So that's where it begins. If we can educate people on bacteria and how to protect themselves from getting infected, we can make a major step towards defending ourselves against bacterial infections and making most pandemics, if not a thing of the past, at least a lot less traumatic than our last pandemic was.
Thank you. Professor Doran.
Well, I think my colleagues here have laid down some of the most important points, which is that the simplest way, most effective way to deal with bacteria is hygiene and education. One thing a mistake that people often make is that they don't really quite understand the differences between viruses and bacteria. Viruses are little scraps of DNA somehow that manage to get into your cell, the DNA in your cell, and reprogram it to create more copies of themselves. But bacteria are actually little organisms that live in themselves. And the reason I'm bringing that up is because one of the biggest problems, or the biggest problem that we have right now, is bacteria that are resistant to the antibiotics that we have now, and others have mentioned that. And one of the reasons that happens is because we we set the stage for them to evolve in a way that is not good for us. And so for an example, and how that relates to the difference between viruses and bacteria is that people get sick and they believe that antibiotics can cure them. But if they have a virus, antibiotics aren't going to do any good because antibiotics work against bacteria, biotics. They don't work against viruses. And so people have for years gone to the doctors, and doctors have just out of whatever given them antibiotics for viruses, just hoping the placebo effect might work, and not really thinking about it. And what that's done is it allows any bacteria that are around to become more resistant to the antibiotics. And another thing that's really, really common is that people have a disease, some sort of an ailment where antibiotics are effective. And it could be anything from a cut that's gotten infected to a disease that you have that is a bacterial disease. And they'll be given a course of antibiotics, which is you're supposed to take 3 of these a day, every day for 10 days or something like that. And what happens after 3 or 4 days, they start feeling better and they think, well, I don't need to take this anymore. And what's actually happened is that they've killed many of the bacteria, most of the bacteria, so they feel better. But the ones they haven't killed that are still there are the ones that are the most resistant to that particular antibiotic. And so what it becomes is basically a mechanism to create more and more antibiotic resistant bacteria. And that's gotten to be such a problem that there diseases that have been treatable for a long, long time, like tuberculosis, are now coming up with versions of the tuberculosis that are resistant to all of the antibiotics that we have. And what the outcome of it is, if you get tuberculosis and it becomes active. I mean, tuberculosis is a funny disease that a majority of the people that have it don't really get any symptoms. But when people start getting the symptoms and the antibiotics don't do any good and they die. I know that the health departments in California try and keep track of any cases that they find of these, because they have to go back to the old style TB treatment, which is just isolate the people. And there's nothing that they can really do. I have a friend who got what's called necrotizing fasciitis. And that's what's known as flesh-eating bacteria. And it just started destroying his arm. Unfortunately, he lived, actually he was a Stanford professor, so he went over to Stanford Hospital, which is one of the best in the country, and they managed to treat it. But his particular strain of necrotizing fasciitis was treatment resistant because it was immune to most antibiotics. And so that's a kind of interesting, scary thing about it. But I also want to talk about, and I'll get back to what we can do about that, but I also want to talk about the good things about bacteria. When we human beings we always talk about saying, well, global warming is going to, kill everybody and all this. It's going to wipe out the humans. The bacteria are still going to be doing fine. I mean, as volume of life on Earth, bacteria are hundreds or thousands of times as many by volume, by weight, hundreds, maybe many thousands or more times as many of them as there are of us. So human beings are we live here at the grace of bacteria rather than the other way around. And we're learning a little bit more about humans. one of the most fascinating things that we've been learning is that there's a relationship between bacteria in your gut and the biological regulation of your body. So one of the newer drugs that's come around is a class called of drugs that are semaglutides, and so one of them is Ozempic, which I hear is advertised frequently on television. But I haven't seen that, but I don't watch television. But the way that it works is that they discovered these signals that bacteria are sending to your brain, and they basically made a drug that copies those signals, and what that does is it tells you you're full. It changes just how your brain relates to food. So people's diabetes goes way down. They lose weight. There's all these amazing things that they can do as they're starting to learn now about how the brain gut interaction. And what's going on in the gut is really got to do with bacteria. So you have a lot of beneficial bacteria in your gut, and all around us, the bacteria are creating the nitrogen in our soil, and they're doing things everywhere for us that are incredibly beneficial. So and in one way, it's possible for good bacteria to crowd out bad bacteria. And so even one way of working with bacteria is the idea of having bacteria compete with each other. And we find the bacteria that are good for us and useful for us and have them outcompete the bacteria that are bad for us. But as far as the issue of treatment-resistant bacteria or antibiotic resistance bacteria, the important things are what Rob and David have said, that if we follow what we know and keep ourselves clean, do the cleanliness standards, and in addition, take that course of antibiotics for all 10 days, because that kills them all. And so then you don't have to worry about the tough ones surviving. And don't take antibiotics when they're not appropriate. Many and doctors have now gotten very much they're very much more circumspect about allowing people to take antibiotics when they don't need them. For instance, I had a cut that had gotten a little bit infected, and I went to the emergency care, and he said, put it in hot water every day, 3 times a day. That's what my parents used to tell me to do. And he said, your immune system will take care of it. He said, I'm not giving you antibiotics. So that's the way that things are being done now. And lastly, I want to say is it's an active research area to try and figure out new antibiotics and ways that we can work with these treatment-resistant bacteria.
Thank you. Professor David.
Donald, I love 100% what you're saying there, but let me throw one other fact on it that I really find fascinating, because so far today we have been focusing on how to treat bacteria that is in the human body. And we've talked a lot about how we're using antibiotics to do that and how we've built up antibiotics resistance and other things like that. And I'm going to come back to that in humans, but the statistic that just blows me away is 80%, fully 80% of all antibiotics go to treat plants, to treat animals that we eat. So it's not just us taking antibiotics. In what we do during the day when we pull plants out of the soil is we go to shepherded farm animals and stuff. They're all being treated with antibiotics all the time as well too. So it's not even just what we can do. And what I love, and I might embarrass somebody in a minute, is that I have sitting next to me here a nurse practitioner who every day she's prescribing antibiotics. Every day she's doing stuff like that. And she made a comment as you were talking about, Donald, that, the hygiene is important. But she also reminded me that people who are super hygiene, people who are afraid of any germ, actually, they probably get sick more because not the many of the good bacteria in, and their body has not built up natural resistance, so that when they do get sick, you have to go to more of an extraordinary means, like the antibiotics and things we're talking about, where the body's own natural defenses can't kick in and do that. And as I look at this one, and you mentioned Donald, the multi-drug resistant bacteria. The multi-drug resistant bacteria market size is just growing so fast, so big. It's growing at a compound annual growth rate of over 10%. And we're going to see that. And we talked about how the markets are driving there. And Sharif, this is again an area where the developing nations have a great role that they can play because of the fact that, you know, Donald, you missed the first part. Bacteria were around over 3.4 billion years before humans. So they're our ancestry and how they play in here. And that they have continued to evolve, just like we've all continued to evolve. And we see those pieces and we see the impacts actually now of more of geography playing in the different strains of bacteria and how they are not. We're seeing how foods can trigger increases in bacteria activity or help retard it. And, I know some of the spicy food I love actually can have interactions upon bacteria. And as you do that, and we see there in COVID and the whole COVID area, as we've looked at how it has put a raise of a new type of vaccines that can combat different types of bacteria too. And we're moving from a time where the drug discovery process of how to treat bacteria, how to treat diseases in general, are moving from a time where it was mostly a manual science process to beginning to do more like we're looking at the recombinant DNA and the recombinant RNA now, to where Rob and I, and Donna, I know you do too now, we talk about digital twins so much on these programs. Digital twins is a great way for us to begin to look today on how we can begin to model new solutions to help beat bacteria. And we are looking at solutions that are not just natural antibiotics, not just synthesized uh, antibiotics, but we're looking at how to modify the DNA. How can we modify the RNAs? How can we go and look at the body pump in our body as a way to treat bacteria as well? Because as we look at those, it happens. And for example, we've talked before about how, for example, a treatment of immunology is being breakthrough in treating cancer because cancer cells have become like stealth airplanes. They develop a shell around them that the body cannot attack and defend itself. Well, bacteria, as we talked about earlier, has done some of the same things. So bacteria has become a stealth bacteria in many ways, which is why some of the treatments for it don't work. And we're seeing now these whole genetic approaches. We're seeing ways to not necessarily use an external drug, but how can we make changes in our own immune system and supercharge our immune system to be able to attack the bad bacteria on their own? And how can we use genetics and modify our immune system to do it? And I personally think part of the topic is how do we beat it? I think that is going to be one of the big approaches for us down the road to get away from just throwing drugs at it, to throwing things in our body that can help our body respond to it more and more. Because as it morphs, if we can treat it, our body will morph to treat it as well too. So that's, I guess, my next round of answers, Sharif.
Thank you, Professor Rob.
Well, Donald pointed out the differences between bacteria and viruses, and it is kind of interesting that while they are the fundamental differences is viruses require a host, bacteria do not. They're a separate living organism, but both can cause illness. Both have antiviral counters to them. You can get immunized against bacteria, much like you can get immunized against viruses. The mechanisms are different. The current antivirals that we have keep the virus from attaching itself to you. A virus dies if it doesn't get a host, and so if you can prevent it from attaching itself to the host, you can kill the virus. Bacteria, not so much, since the virus doesn't really attach itself to a host. It just disrupts the host. Disrupting its attachment doesn't do anything since it doesn't attach. So the antibacterial stuff tends to try to kill the bacteria or develop immunal responses, which is actually the more accurate term, that allows your body to kill the bacteria. And much like some of the earlier antivirals, where you were using your immune system as opposed to protecting against attachment, what the effort is to build you up, and so so the bacteria does not hurt you. Donald's pointed out there's good and bad bacteria. That one of the arguments right now is to not wash as often as we often do, because when you wash, it not only removes the harmful bacteria, it removes the helpful bacteria as well, and can cause things like premature aging or make you more vulnerable to hostile bacterial elements. So there are aspects about this that are kind of fascinating, but in the end, many of the protections that you use against viruses also are effective against bacteria. You want to protect against contact. You want to remove it from the surfaces that you eat on. You want to make sure it doesn't get into your food sources, the harmful bacteria that is, into your food sources. I'd probably argue that there are viruses out there that aren't harmful either, that only affect animals or plants, or aren't effective against humans. Much like there's bacteria that we're around all the time and doesn't bother us at all. The big problem with both viruses and bacteria is if you're immunocompromised. If your immune system is not up to snuff, either a bacterial infection or a viral infection can cause you a significant amount of damage, because your body, which is your greatest defense, but greatest natural defense against both elements, is compromised, and it can't execute that defense. So anybody that's immunocompromised should certainly not be doing things like shaking hands or kissing other people or being in close contact, because whether it's a bacterial or viral infection, you don't want either one of them, because chances are you won't be able to fight it off. And your symptoms, if you survive them, will be far more severe than somebody that isn't immunocompromised. But it still comes down to, if you want to fight a bacterial problem, you're going to use some of the same defenses that you're going to use to fight a viral problem. That means you're going to want to make sure the surfaces you're eating off of are clean. You're going to want to maintain a social distance from the people that might be infected, and you don't want to take unusual risks, kissing, shaking hands, and then eating, not washing your hands. Those are all things that will spread both bacterial and viral infections, and so learning those practices can do an awful lot to prevent the spread of problems. And often with the spread of bacteria, it's foodborne or through contact. You come into contact with something that has the bacteria on it. And some of the shots for that, I still remember the tetanus shot that I had a few years back, when I was a very attractive nurse comes in and she tells me to pull down my pants, and I'm saying, I'm an adult now. I'm big enough to take it in my arm. And she says, no, it's got to go in your butt. But if you want, I'll close my eyes when I give you the shot, which didn't appear to me as being any more attractive than taking the shot in the arm. Playing pin the tail on my donkey's butt was not an exciting outcome for the event. But in the end, you've got to address this stuff fairly quickly. We've got flesh-eating bacteria. We've got a lot of bacteria that's pretty nasty, and the stuff does evolve. In fact, there's an argument that bacteria has a form of intelligence because it can work its way around, and virus in much the same way. They can evolve around the protections we have in place. Bacteria has been able to evolve around and become immune to antibacterial agents. Viruses have clearly evolved around the antivirus treatments that we've got, and so even though these are microscopic creatures, that they do have the ability to evolve, and they do act in a somewhat intelligent way, though you can certainly argue that anything that kills whatever supporting it isn't the most intelligent thing in the world. And then you go back to our previous topics on global warming, and you might argue we may be no more intelligent than they are. So in the end, it really comes down to education, making sure people are aware that they're microscopic organisms, either viruses or bacteria, that they need to protect themselves against, and then really having some consistency with regard to the recommendations that government is providing and the enforcement that they're providing against the spread of either bacterial or viral agents, and certainly assuring that nobody weaponizes this crap. The one element that we really want to avoid, because our protections are so poor in this regard, is this idea that you can release a viral or bacterial agent as part of a battle, and that's going to end well. These things do evolve, and so you might release it, and maybe you've immunized your forces against it. But if it evolves in the field, that immunization, whether it's a bacterial immunization or a viral immunization, may no longer work, and now you've got an out of control problem, depending on how it's being spread. Now, granted, because of the nature of the spread, bacterial spread is probably safer than viral spread, but I'm not going to argue that it's wise to do anything that the people that are spreading it fundamentally don't understand, and spreading an invisible agent to do harm. Just to me sounds like there's so many ways that can go wrong and go badly. Going back to the mustard gas uses in the First World War, that was just largely seen as, this is not the way to fight a battle, and to a large extent, chemical weapons have been removed for the most part, except for some pretty bad instances in Syria, have been removed for the most part from the operational capabilities of most of the developed militaries. But we don't want to go back to a point where we start exploring some of this stuff again, because once you let these genies out of the bag, it is very, very hard to recontain them, and you could end up doing far more harm than good. This is an area that's getting an awful lot of focus, and for good reasons right now. Our penicillin is becoming less and less as a viable antibacterial element because the bacteria has evolved around it, and the antibiotics are less and less effective. In fact, the more you use them, the less effective they become. Your body evidently develops immunization towards the antibacterials, and so if you're using them improperly, they may not work when you need them. And so using an antibacterial for a virus is not only it's not helping you with the virus, it's making it less likely that antibacterial is going to work if you have a bacterial infection. And with a flesh-eating bacteria or brain-eating bacteria or some of the scary crap that's floating around, you really want these antibacterials to work and work effectively. So in the end, though, back to my premise, it's all about education. If people are aware of the behaviors that keep them from getting infected, then there'll be less people infected. And our problem right now is twofold. People are not aware, are not actively aware of what to do. And number two, they don't really trust the government's advice with regard to anything in this area. And if we don't fix both of those things, it's going to be very hard to defend against the next virus infection or the next bacterial spread. And we need to be able to defend against both.
Thank you. Professor Donald.
You're still muted.
Unmute, please.
Sorry. I'm really glad David brought up the point about antibiotics being used in many places besides human beings. When you go to the store now, they have antibiotic-free beef and everything else like that. The chickens were raised without using antibiotics. And they were pretty indiscriminate about using antibiotics in animals because, what the hell, we'll just give it to them. They probably won't they get sick less. And so we have more animals that we can chop up and sell to people in the supermarket. And so that's a case where we were making a breeding ground for bacteria to get more resistant to the antibiotics. I also like what both Rob and David pointed out is that when you talk about hygiene, you don't want to have hyper hygiene. You don't want to go nuts. I'm thinking about the hygiene of being sure to wash hygiene, like when you get cholera. I mean, cholera has to do with bad water. It has to do with bad sanitation. And in those kinds of cases, cleaning yourself better and making sure what is around you is more clean is the form of hygiene that's really great. But stopping your kids from going out in the yard and eating dirt and stuff like that isn't good, because that's actually builds kids' immune systems are great. They're really, really strong. And that builds up their that exposure does build up their immune systems and makes their immune systems work better. I feel that I was very blessed that way. My parents would always let me eat dirt or whatever I wanted to do. You try it a couple times. You don't do it more than once or twice, but still. In any event, going back, I want to revisit. Well, the idea that I mentioned before of the idea of good bacteria, and they're all good. I mean, human beings are just a pain in the neck on the earth. In some senses, the bacteria really are by far the major life form on Earth. One of the ways that people have been starting to help take care of plants is using bacteria as a way of fighting other bacteria. So that you actually spray bacteria on plants, and there's bacteria that will prevent yeast from attacking the plant. There's bacteria that will have different purposes, and they can actually be used in place of pesticides and herbicides and other you don't want herbicides on plants if you want to keep them, but pesticides and other kinds of things which are detrimental to people's health. The good bacteria will crowd out the bad bacteria. I also want to go back to what they both mentioned about the immune system. And right now, one of the real promising things they do with cancer is that they one of the things with cancer is that the cancer comes from your own cells. So your body doesn't recognize it as a bad thing sometimes. And that's one of the problems is your immune system just doesn't see it. So your immune system doesn't do any good because the immune system doesn't kick in because it doesn't recognize it as something that's an invader. And they've discovered that there's a certain genetic sequence that causes that to happen. And so one of the promising things they've done with some forms of cancer is to go in and have the cancer do something like they've been doing with the mRNA and change the cancer cells so that the immune system recognizes them as an invader rather than as part of their own body, and then your immune system will then attack it. And that's actually been working pretty well. It's complicated because cancer isn't one thing. Every single kind of cancer um, kind of relates to the particular cell and the particular environment. So being able to come up with a general solution for this hasn't really happened yet. But I actually know a person that had stage 4 lung cancer, which is absolutely fatal. And they used one of these new treatments on her, and all of her tumors shrank, and she's just fine. She's completely cleared. And so we are making progress in this direction. And as David pointed out, we are more able to look at the actual genetic sequences of these organisms and be able to target certain kinds of things in these organisms. So I think it's important to remember that there are good bacteria and there are bad bacteria, to just understand overall that actually, there's one other thing I wanted to mention. David talked about the fact that bacteria shuffle their DNA between each other. But all of us do that. And in fact, our mitochondria, which is the powerhouse in our cells that gives the cells energy, was actually a bacteria that combined about 1 billion years ago with the cells of higher creatures and merged into us. So all throughout us, we have bacteria in our cells. We have fragments of bacteria, and so we're partially bacteria. And I mean, that's what makes it tough to find a way to kill them, because if we kill them, we're coming up with a pretty good way of killing ourselves. But I think that the promising areas are, as David and Rob pointed out, to look more at how we can get our own bodies and our own immune systems to be able to target the bacteria that they're not able to now. I mean, you have bacteria all the time in you. I mean, there's tons of it. You have bacteria all over your body that could potentially become flesh-eating bacteria and kill you, but it doesn't, because our bodies have figured out a way to deal with that. And so I really like the idea that as we learn more about the structure of the bacteria and viruses that we live in a world of, that we can alter or teach our bodies to be able to deal with them in a more effective way. Oh yeah, and by the way, David, my nurse practitioner just left to work. The one that's usually sitting right in the room while I do the show. She would be commenting on it, I tell you, I assure you.
I am getting comments from this side as well.
Okay.
Wrap up, Sharif? Closing remarks? Yeah, to me, this is a very interesting problem because it has the differences. And Donald, one of my favorite discussions when I was on the Innovation Advisory Boards for National Institute of Health was actually with the scientists that were jumping deep into immune therapy and how that is. And like you, I have a friend who was metastasized stage 4, and they used immune therapy as part of their treatment. And they didn't cut and burn, but they used the immune therapy. They used some cryo and some radio frequency stuff. And it looks like at least it stopped in its tracks now, and see where it's going. But the nurse practitioner here with me actually came back and said, for example, the antibacteria hand wash that we use very often is actually, while it's good, it actually has challenges with it, because it does increase our ability to do it. And I know people who put that on 30, 40 times a day, and it's beginning to get it. But the other thing that she reminded me of, which fits directly, Sharif, with your target audiences here, is that the underserved population, be it underserved like in the United States, or if I'm in South Africa, if I'm in parts of Brazil, or even parts of Asia and Europe and here, we have this underserved population that Rob talked about the importance of education. I agree. You've heard me talk about lifelong learning, group intelligence so often, but that underserved population is one where bacteria is still a challenge with them. Understanding. Uh, she mentioned a patient that they just kept upping their antibiotics for an issue and stuff, but then they walked in when he wasn't expecting them, and you saw all these things around his room that was bad for him, that the drugs were supposed to counteract, but he was going the other way. And there. But Sharif, I want to go back to your target on this. As you see, there's so many things where this is continuing to morph, continuing to change. The universities, the colleges, in the developing nation, this is an area where they can still play a role because we need innovative new approaches. We've talked about the role of innovation, and developing nations will attack it differently than developed nations. We've talked about the roles of entrepreneurship and startups. Bacteria is one where the approval cycles for what you're doing against uh, bacteria is not as long as it is a chronic disease and stuff. So entrepreneurship can be much greater. And finally, we talk often about the government. The government can help put things here in place too, particularly as we see the new forms of genetic-based approaches to deal with antibiotics, and as we see the ability to look at public-private policy. Donald, you mentioned social distancing before. I'm sure your nurse practitioner and this nurse practitioner both said, we love that, but it doesn't work. And so we've got to look at ways to address this in a more uniform area, that drug-resistant antibiotics from the United States, if they're exported into a developing nation, it might have consequences there that it wouldn't have here because of the way our ecosystems are different, how our bodies have different reactions to it in the developing versus here. So Sharif, I don't know where you come up with all these topics, but this was an excellent one today, so thank you.
Thank you. Professor Rob, what's your concluding remarks?
This will just be quick. The way to fight bacteria is through educating the populace and creating a higher level of trust between the populace and government, so that responses against bacterial infections or viral infections can be both timely and effective. Without that, we'll be talking about these problems for the foreseeable future, because in reality, when fighting this kind of a foe, we're our own worst enemy right now.
Thank you. Professor Donald, what's your concluding remarks?
Well, my nurse practitioner likes us to get together outside when we can and keep a bit of distance, because it's pretty clear that the COVID virus is very fragile, so that you can make a situation where it's harder to get it. But regardless, back to the thing at hand is that and I also want to say that I agree with David and his nurse practitioner that my wife is very much against things like antibacterial dish soap and things like that, because what happens is it's the exact thing that I was talking about, is that the bacteria that it doesn't kill them all, and the ones that it doesn't kill are more resistant to this. And so what we're doing is we're basically breeding bacteria that are more resistant than we'd like them to be. But on the flipping around, I'd like to agree totally with what Rob said, that most of the problem with bacteria in the world have to do with, and I'm going to use the word hygiene, but I'm going to also point out that I'm not referring to hyper hygiene, like washing your hands 15 times a day and rubbing alcohol and everything and stuff like that. I'm talking about having good sanitation, so people have people have clean water. They're not exposed to human feces and other sources of bacteria that are potentially have diseases in them, and that they learn by hygiene. I mean the useful ways of reducing your exposure to bacteria that might be harmful to you. And so when we're talking about, reducing the problem of bacteria, the number one way to do it is just to improve the infrastructure and education for people, and that will take care of a vast amount of the global problems that we have from bacteria.
Thank you. Thank you, everyone. This is excellent sessions. We are creating awareness. We are organizing focused group discussions. We love to learn from each other, and we are doing real-time projects. So your contributions is priceless. And through this process, actually developing nations learn from developed nations, and we minimize the gap in between developed nations and developing nations. Thank you, everyone, for your continuous support for World Talent Economy Forum, because today we finishing our 650 episodes. Thank you, everyone. Thank you. Bye bye, and take care.